So my project here is the fake news detection, and my objective is to detect a fake news based on the headlines / text, and I would want it to output a binary value, 0 for fake, 1 for true, and I would like my validation data to be something that I already need the truth to, so I can easily see an accuracy. And I want to have two types of input, manual and scraped. So the first step I do is the file processing. And this step right here is important, but I'll get to that later after I show this. So finding the right data set for your model is essential to success. So this step is extremely important, and the title, text, subject of the news of this first data set, because I used three CSVs or 2 data sets. The first data set had 2 separate files for fake and real news. And in the first data set, I need to remove the title. I'm not using they had a title, text, subject, date was include columns that this data included. So it had significant data, but I only end up using the title, text, and the truth. But for truth, it's already known because they're divided into 2 separate CSVs. The second one was scraped from the fact-checking website, and was an extra one to improve my accuracy of my program. And after loading the data set, I processed it and loaded it and made it easier to use. So basically here is how it looks like after I concatenate the data sets, and this is how it looks like after the entire file processing process. And here's me reading it, the CSVs, and of course I'm setting the truth, the truth. I'm creating this truth column and making fake news data set and the true news having a binary value of 0 and 1, or true or not. And here is a really important step that I said I would get to later, and this basically cuts off the fake news data, because if you're looking at majority of the data sets, fake news is more prevalent than real news, and so there would be an imbalance. So I have to cut it off, and this actually really changes the tide of the program. It leans the program to one direction or the other. So of course you can see the value counts of trues is a little lower than false. Lowering this value could make the program lean more true, and that can improve the accuracy. That's one thing I could have done. And text pre-processing is the second step. And after the data is set, the text needs to be pre-processed and readable by the program. And I use a set of functions and then use lambda to apply. This is what I did here. I have this function remove contractions, and then I apply using the apply function. I use lambda to remove the contractions. And I do this for both title and text, but I only end up using text at the end. This is just a test. The title is for testing. And the pre-processing includes expanding contractions, remove punctuation, and stop words. And those are the functions. And this is how it looks like after I do the pre-processing. So here's visualization on after I pre-process. Here is how, this is pre-processing. This is how the frequency of words are shown in this word cloud. And as you see, the word Trump is common in both of them. This is so in real news and fake news, but it's more prevalent in fake news. The word said is also common. So these keywords are what the program, I assume, looks at or what leans it. These are weighted words that lean it to one direction or the other, or they might balance out like said and stuff. And of course, I use scikit-learn for this project. I chose it over the other ones because it has many useful NLP features and is easier to use. And I use the classifier multinomial naive Bayes. It's MNB for short. And so in order to perform this classifier on the text, we need to transform our text into vector representations. This must be done because the classifier only understands a numeric vector of the data. And the vectorizer I used is the TF-IDF vectorizer. After this vectorizer, and then I implement a transformer and a TF-IDF transformer. This basically normalizes the data, and I run the classifier as the third step, as you see here. So I do the vectorizer, I do the transformer, and then I do the multinomial naive Bayes as the final step in the pipeline. So this pipeline makes it much easier for me to run it instead of having to vectorize the data and then go to, it does it all in one step. The moment I say text underscore CLF.predict, it does the vectorization and the transforming, or transforms it for me. So it makes it much easier and I can put it predicting into one line. Here's my confusion matrix heat map. So, of course, this comes with the 88.91 accuracy on testing and a 99.99 accuracy on training, which doesn't really matter. This matters. This number matters. But here, as you see, here's the confusion matrix in this heat map. Of course, 45.90 are true negatives. But there's, as you see in the previous slide, there are actually more true negative or actual negatives than this. And then you have true positive here, which is 43.1. And then you have almost an equivalent distribution of false positives and false negatives, 5.69 and 5.39. And then you have this this other confusion matrix, which has precision, recall, and F1 score. So precision is the true positives or the total predicted positives. And here's the percent for false and true. And then recall is the true positives over total actual positives. Here's the percent right here. And then F1 score is sort of an overall look at the precision and recall. And so it's 2 times precision times recall over precision plus recall. So these are really important metrics to see how accurate your model is, because just getting these values aren't helpful, especially this one. It's not very helpful, this training data. It looks good, but it's probably not it's not very useful number. So input and pre-processing, user input. So this is what I have 2 options I'm doing. And I'm doing manual and scraping. So basically manual mode is entering it in, it's what it seems like. It's just you enter in your own value into the model. And then you have scraped, which is basically this. And it basically asks you, which one do you want to pick? True, mostly true, half true, barely true, false, and extremely false. And it gets it from this website. And of course it appends these things, and this is how it scrapes. And then classifying. And it basically runs the same things that we did in the model, and it outputs an array of predicted values. As you see, the first value is true, the second value is the first value is false, second value is true, third value is false. And then here's what I do to predict, and as you see, it comes out like this, where it has this label, this extremely false label, and then it has the binary predicted value. Then here's where I'm going to get accuracy and the flaws of this model, and how I can improve it with changing that initial step. And here's 6 categories you can scrape. I already went through these. So of course, you have an input, and then it gets data, and this is basically the scraping process. And then, as you see, here's the actual accuracy of this specific data, though. It's this specific data. and it has a 60% for true values. As you see, it has 18 predicted or actual or true positives, or yeah, total actual predicted positives. This is true, and then it has 12. And then if I had a bigger, this is only 30 values. As you see, this 30 values. These are not the same values. These are like separate data sets. And as you see, mostly true, and then half true, and then barely true hits a high with 80%. And then it stagnates at 73 here. And then here's a slide where we're talking about the thing, or the more specifics about it, the precision and recall. And then using the formulas I did, I said before in the previous slides, I calculated the precision, recall, and F1 score. So here's the matrix. I only took since there are way more true false data points, or false, because as you see, there are more barely true, false, extremely false, and half true. There's like 4 of these. Well, there's only 2 of this. So I only took 2. I took barely true and false, which is barely true, or barely true and false. Barely true and false, right here. Barely true and false. And then I take that, and then I take barely true and false, and I take the true and mostly true data, and then I combine them together to get this confusion matrix. And as you see, this is not very good. Negative positive is 30, while positive is also 30, which is not very good. But as you see, the scores aren't that good with this specific data, though. But I can always balance it, and of course, precision 68.18, recall 50%, and F1 score 57.78. And here are my credits. I'm going to show my code now. Of course, I use these data sets from Kaggle, and I got some visualization from the source. And then this website really helped me a lot. So let me move on to my code. Hopefully you can see it now. So I have these 3 sections, or 4 sections. Import, preprocessing, model, input, and prediction. First, we're doing import, and we're installing this contractions module, and then we're importing my drive, and then this is making, I already discussed this part where it makes zeros and ones, and then this is basically pre-processing this extra data set, which is basically the second data set, the fact-checking website it scraped. That's the second data set, and this remove slash. This just does a few pre-processing things to make the data set more easier to actually pre-process. And this is what I was talking about, how it balances the data and it changes it. Pre-processing, here's the functions, and this is basically the pre-processing I showed you before. And visualization, here's the word cloud, how it's coded, and here is how it shows. So the model, here's the important part, the model, and then some of the values are objects. And so for some reason, the data set, this extra data set, comes with objects in its data. It's not integer values, the truth column. So so I had to convert it to integers, int values. And then I made x the news join text, and then I split it. And then I do this pipeline that I showed you in the slide, and I already explained what's the benefits of using the pipeline. And then the scoring, here's the scoring 99.99 or 91, and then 88.91. And then precision and recall vectorization, or visualization, I mean. So this is basically this heat map I showed you in the slides. And input manual, where you can enter any values in, and it'll output this array. And scraped, and this is the scraped part. So basically, it make sure you enter an integer value. This is what the try and accept thing is. So basically, if it's 1, it makes this thing true, and then it appends that page. It takes this page thing and appends it, and then it prints out the data URL. And then this basically does pre-processing and makes sure we get the right data. This is the important part of code where I learned Beautiful Soup, the library for this project, and you have to take you have to go on the exact elements and classes that the thing is on the web page, the text you want. And here's the prediction where it pre-processes it, and then it scrapes it displays the scraped data, and here's it with everything. So that was my project, and manual is the same. So
thank you, Ishan. Professors, do you have any questions for Ishan? Professor, are you telling something? We are not able to hear you.
I guess we can move on to the next presentation. Joseph and Ishan.
okay, maybe Joseph wants to, or Indian wants to start. So